This evening we're working on Chapter 5. Chapter 5 is an important chapter because it deals with uh, one of our next steps inside of structured programming. The whole concept of structured programming, which is talked about, that last section here in the PowerPoint section 5.4, the author goes into a little bit of a talk about what structured programming is. And a good part of structured programming is taking things that we very commonly do in our code and kind of putting them together into named modules. Um, and in this case, we'll be looking at both functions and sub-procedures. And other languages will call these different things, in some cases methods or just functions. And really what this does is it allows you to take that code that you might use very often and group it together and then call it by name. So if you wanted to perform a specific action, you just call out that name and it does that whole series of steps just by calling it out. Now you can see there's advantages to this in making for really clear program design. And there's also the reusability factor, which then ultimately leads us over to object-oriented programming in the end. Something that's a little beyond the scope of this particular course, but we do get a little bit of an introduction to it. So let's move forward here and take a look at the first slide here. So the way that Visual Basic works is we have two types of structures that we can, as users, create in order to create modules of code or sections of code. One of them is called a function, and the other one is called sub-procedures. We'll begin by looking at functions. And we're going to look at a few different types here. We'll look at a bunch of different examples. But we're going to begin by looking at functions that have one parameter, and I'll explain what those are. And then ultimately we'll look at some that have several. And then we'll also look at moving values from one part of code to another. So if we create subroutines or functions, data that sits in memory, if the variable is in or out of scope, might not work in a different subroutine, so there's ways for moving the data around. We'll also look at a couple of other different concepts there too. But let's take a look at some functions that are already built into the language, just to kind of give you an idea of what the syntax kind of looks like and what kind of happens when you actually use a function. So there's one function that's built into the language called int. An int, as listed in the example there, you would call upon it by just using the keyword int, a set of parentheses that follow, and you can see this is kind of a theme here. And then inside those parentheses is a value that we're throwing at that function. And this one's pretty easy to figure out. Int basically takes a number of some sort that's got a decimal value and converts it into a whole number. All right? So there's an input that you give it, which is a number, and it's got some sort of an output, which is also a number. So notice that is a commonality. First of all, that we call it by name, we send it a value inside of parentheses, and then it returns a value to us. And those are three really important concepts there. So you're going to see that pattern repeat with these other examples. Another one that's built in, and this one you'll see in lots of different languages, is they'll have math libraries, and there's a function built in called round, which, guess what that one does? You throw in a value, and then, oh, there's a comma in there, and then the number 1. So what this does is it takes the number 1.23, that's the number we're sending to it, and then we're also sending a value that says how much do you want to round it? One decimal place is basically what that one means. So if I send 1.23 into math.round, it will send back 1.2. And let's say if I sent in 1.234 and I had a 2 here, it would round it to 1.23. So you see how that works, right? That's a really good question. You know what? I would try that before I would answer that question. I would think that if I put in a 0 in terms of the second digit is what you're talking about, yeah, it would probably round it to the whole number. The other question was? Well, that I don't really know. Typically, a method or a function like that has certain number of parameters it accepts. In some cases, you can do what they call overload those parameters. In other words, send in more than one parameter depending on how the function is designed, but I don't know that documentation off the top of my head. But what I can tell you is that I think it's most typical with that one that you do declare the value going in and how many places you want to round to. And you know, Max, you might be right that maybe it automatically sets itself to 0 if you don't put something in there. But that's not something I retain in my memory. I just, you know, as I type it in, you know, Visual Studio will remind. Yes, yes, absolutely. All right, but notice the commonality. Once again, it has a name, set of parentheses. We throw in some values. Notice in this case, we're throwing in 2 values separated by a comma. Each has a special meaning to the receiving function. Ultimately, it will return a value to us. Take that a little bit further. Functions are not only limited to working with numbers, but they're also capable of working with strings or characters. In this case, there's a function called CHR, and if you put in CHR65, that's basically the ASCII numeric code for the capital letter A. So if I type in CHR65, it will return an A. In addition, if I run this function here, the ASC, that one actually takes it and converts to ASCII. And if I send in Apple, it sends back 65, which interestingly would seemingly only return the value for the capital A. So I'm not sure what other parameters go with that particular function, but I would guess that there's probably many. All right. So let's talk about functions in their general form. You'll notice that when we use them, that we always precede them with the keyword function. So we're telling Visual Studio and Visual Basic that we're creating a function. And then right after the keyword function, we will actually come up with a name for the function. The name is case sensitive and it must be unique. It also cannot use one of the keywords that is part of the Visual Basic language. So I couldn't call my function if, for example. But I could call it by something a little bit more meaningful. Then notice that we have a set of parentheses there that follow. And inside those parentheses, we are declaring basically variables right inside that statement, meaning that this function is expecting to receive these variables as arguments. So in other words, wherever we're going to call this from, we're going to be sending stuff to it. Every time we do that with a variable, we'll declare it by name. So it's got to be a unique name to that function and its data type. Is there a limit to the number that you can pass? I'm not really sure what that is off the top of my head. I know it's huge. You can pass a large number of items over to a function. But usually seeing 1, 2, 3, 4, 5, something like that, that's pretty typical. All right, so the ... in this situation really indicates that as many variables as you're passing to it. These need to be predefined. So if you were doing some sort of a calculation, let's say you were trying to calculate sales tax, you might want to send it the total purchase amount and maybe the tax rate, for example, or something of that nature. Notice after the parentheses here, though, that we have this as return data type. And what this is indicating is that when the function is done doing its work, it's going to be returning information, and that information that it's returning is going to fall into a certain type of data format, right? Could be an integer, could be a string, could be a double, could be a decimal, could be a character, could be any of those things. But that has to be declared here prior to being able to return it. So that's kind of the general form of the header. In terms of what happens inside of a function, well, any statements that you write, any regular programming statements, whether it's math or output or whatever it happens to be, usually some sort of processing is going on here. And then at the very end of the function, we put in a statement that's called a return statement, and then it returns some sort of an expression. It might just be returning a variable, it might be returning the result of some math, but whatever that return item is, that has to be in the form of a data type that matches the one that's indicated here. So if I did some math and I came up with an integer answer, this would say as integer, and whatever this is returning would be that integer. Probably the best way to see it and understand it is to look at an example. So here they have one that's called function F to C. And what that does is it converts Fahrenheit to Celsius. This is expecting one parameter, so we're going to be sending it one thing, and that thing is going to have a variable name basically of T for temperature, I'm assuming, and that's going to be in the form of a double, so that means a decimal number is allowed, and then whatever value we're returning is also going to be a double. So you might imagine that if I sent something like 75.3 degrees to it, it would do this math and then return a number that's also a double, or potentially a double. And notice this one is really pretty straight ahead. There's not a lot of statements in here. In fact, there's not any statements aside from the return statement. And what's happening in the return statement is there is the mathematical formula that's used to convert from Fahrenheit to Celsius, and that happens to be it. So 5 divided by 9 times T minus 32. So if I were to take a number and drop it in there, so if I dropped in the number 212 degrees Fahrenheit, it would do the math and come back with a Celsius temperature of 100. So wherever I called that from would return that value. So let's take a look at this one more time in terms of kind of like the terminology that goes with it. Once again, we see that keyword function here. There's the name of the function that follows the keyword function. That is case sensitive, so wherever I am going to call that from within my program, and that can be anywhere within my program, I have to use that exact syntax, followed by a set of parentheses. Since this function requires that we send it a number in order to operate, wherever I would call this from, I would have to stick a number in there or a variable that holds a number. Finally, the return type of the result of the function, which again is a double. So if you looked at this in terms of what the program might look like on the screen, you'd probably create a little form where you'd input your Fahrenheit, press the button, and then it would output the Celsius. So in terms of an overall program, you might see something that looks a little bit more like this. So you create your form, you give that button a double click, and it would automatically create this subroutine or sub-procedure, which reacts to the button click. Inside that sub-procedure, you create a variable called Fahrenheit temperature and then Celsius temperature, both as doubles. The Fahrenheit temperature is going to be grabbed from the form, so we're doing the conversion to double, grabbing the text from the form. Remember, whenever you see these C doubles, you know, we're doing conversion, so that option strict is on. And that really is the better way to program, folks, and that's the mode you should try to stay in for the rest of the course. So you do that conversion to a double. Whatever the user types goes into Fahrenheit temperature. Then notice for the Celsius temperature, that's not something that they're going to type in. That's something that's going to be calculated. And this is a real important concept, one you might want to highlight and notate and put an asterisk next to. And that is, whenever we make a function call, and this is a function call here, so you can see F to C, we'll call the function, and then we're going to pass to it some sort of a value. Now that value is the one that the user typed in the form, right? But because a function has a return type, we can't just call the function and expect the return type to go nowhere. Anytime you have a function call that returns a value, you typically will want to have some sort of a thing that's going to receive that value. In this case, the variable called Celsius temperature is going to receive the return result of running the Fahrenheit to Celsius function. All right, so just to kind of reiterate that, set up our two variables. We grab the temperature from the form, convert it to a double, drop it into this variable here. Then we make a function call with that temperature. So let's say we typed in the number 32. We're sending the number 32 down to the function. It's received and placed into the letter T. And then that 32 minus 32 is 0 times whatever this turns out to be, which of course is going to be 0. And of course 32 degrees Fahrenheit equals 0 degrees Celsius. And then that value would be returned back here and then gets put into Celsius temperature. So that's kind of like the mechanical procedure of what happens. So whenever I make a function call, that value gets transported to this function. So it comes down here and finds it. Whatever's inside the parentheses gets put inside the parentheses, and then that variable gets used here. The math is completed, and then it returns this data type to where it was called from and places it inside this variable. Then we take that variable and display it on the screen. Now I know that that's kind of a lot to absorb all at once, especially the first time you're exposed to this, but I will repeat it many times over, and then when we start to do our lab exercises and stuff, I'm hoping that that'll pop into focus a little bit more clearly. All right, so here's an example. Type in 212 degrees. That's the boiling point of water, and that's 100 degrees Celsius. So that, if it works, that's what you're supposed to get. Here's another example using a function with one parameter. In this case, the function is called first name. First name will receive a variable called full name as a string. So we're going to be sending a string to it. And then it's also going to have a return type of a string. So when it does whatever it's done with whatever it's doing, we're going to send that string back to wherever it was called from. Inside the function, we declare a variable called first space as integer. And then we run this little procedure here. It says full name, index of, where it's looking for a space. So what it's trying to do is get a person to type in their full name. So Joe blank Smith, for example, right? And as soon as it finds that first space, we're looking for the index of the first space, then it's going to return the substring that begins at position 0 up through the first space. So these are all like little, I'm not really worried about these procedures, these secondary ones, but the whole point is it finds the first name in that and returns just that string. We're sending it a string, which is a first name space last name. It looks at it, reads the first name, finds that first space, and says, okay, I'm done. And then it grabs that first part of the string and returns it. Okay, we send it a string, it returns a string. That's the procedure. What it might look like as a program, spot for us to type the full name, button to click, and then where it's going to return it. In terms of the program from a more holistic standpoint, the code that is triggered by the button click will have a variable called full name. That full name is going to be text that we pull in from the form. Now, remember, when we're pulling in a string from a form, we don't need to convert it to a number. So there's no conversions going on here because whatever you type in a form is text anyhow. Right? So it gets stored in full name. And then what we're going to do is we're going to run that function, name first name, and pass to it the full name that we typed in. That will do the procedure that we talked about, and then ultimately we'll return just the first name, which would get placed directly back into that bottom text box, so you would see something that looks like this. If I typed in Franklin Delano Roosevelt, it would return Franklin. All right, so that was an example using both numbers and strings of running a function that accepts one parameter. All right, now we're going to look at one that accepts more than one parameter. All right, And we kind of saw this in that real early little example that I gave you, where we set up a function, we give it a name once again, and now with this one, notice that we have two values going in. One is a wage, which is a decimal number, and another one is hours, which is also a decimal number. Whatever this thing does, as the result of it, it will ultimately return a decimal value to wherever it was called from. All right, so let's walk through what the code does. We set up a variable called amount. That's a decimal, and apparently that's the amount of salary. And then we look at this case statement that says, given whatever number of hours you type in, if it is less than or equal to 40 hours, then you just get your wage times the hours. So in other words, if you get paid $10 an hour, you work 8 hours, you get $80, right? If you happen to be working over 40 hours, then it's going to take your wage times 40. So the first 40 hours are at like a standard pay rate. And then after that, we will go at 1.5 times your regular rate for the subsequent hours. If you want to check the math on that, you can. But basically, if you worked 42 hours, you work 2 extra hours, you get time and a half for that. When this is all done, depending on if you're working full-time or over full-time, bottom line is the amount variable will be populated with what you should be getting paid, and then that will get returned to wherever this function was called from. Once again, just a real quick little example of what a program like this might look like. Spot where you would type in your hourly wage, so $10, $50 an hour, whatever it happens to be, and then the number of hours that you've worked. So what's nice about this is able to actually adjust to whatever pay rate you have and however many hours you work. Pretty simple little program, but actually pretty effective. So press the button, and then hopefully you'll see your earnings here. Once again, from the holistic view of the program, where we click the button, we will be reading in from the form the hourly wage that you got up here and the hours worked. Each one of those will be converted into a decimal format from the form and stored in the appropriate variable. Pretty simple. And then in order to get the output back up onto the screen, and look at the syntax here real carefully. First we do the function call, we call the pay function. We send to it the hourly wage and the hours worked that we determined by grabbing it from the form. That will actually jump out to that routine here, do the math. That number will come back to this spot in the code, and then it will get converted to a string. Do you guys know what the C does? That's the currency format. So it's converting it to a string in the format of currency. Now this is a little bit different than what we saw before, because you could also take that format currency method and wrap that around the whole thing, and that would work too. But this is, the author's basically showing you a couple different approaches. So don't be confused by seeing that. You could just take that whole pay, hourly wage, comma, hours worked, and then put that inside of parentheses following a format currency, same difference. Okay? All right. I'm hoping that helped to clarify things a little bit. All right, moving on to slide number 20. All right. It is also possible to do functions that actually do returns of Booleans. And I'm not really very concerned about like what's going on in this particular thing, but the whole point is that you can run code that checks for a certain situation and returns a true or false instead of a number or a string. So that's a possibility too. What the scenario might be in this case, you know, they're trying to say is vowel word. So I'm guessing that if they're looking at something being a word that starts with a vowel, they would find it and then just say true or false. And you know, that's all the information you would really need. One last little thing before we move on to the next section here is there's also the possibility of inside of a function putting in a little thing that says exit function. And usually what you'll do is you'll have maybe like an if statement or a select case statement, something like that, where a certain scenario might hit, and instead of actually completing the function, you just put in a little thing that says, get out of here, because we don't need to do it. So maybe you would write a statement where somebody says, you know, what's your hourly wage? 0. So the point of us returning something is pretty pointless, right? You know, if you're not working for any pay, why are you throwing it in here? Just an example. All right. So that covers the concept of functions, and functions are basically something that we create. We send values to it, it does something, and it returns a value. Keep in mind that whenever you work with those, when you're returning a value, that value has to have somewhere to go when it comes back. Usually, you'll see a function call on the right side of an equal sign with a variable or an output field of some sort on the left. That's very typical. All right, so let's take a look at the other concept now, which is sub-procedures. And sub-procedures we've actually been working with all along. Whenever we like take that button and we double-click it, and it creates a little thing of code for us, if you guys looked at it, you'll notice that it'll always say, you know, private sub, blah, 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 underscore click, and it handles the button click. And then inside there is where we were putting our code. All right, that's kind of the overview of it. Once again, we'll start by looking at kind of like the general form of it. And really the thing that's different here is the fact that instead of using function, we use the word sub. And really what this stands for is subroutine, sub-procedure. You might hear people you know, calling these things by different names. Really the only difference between a sub-procedure and a function is that a sub-procedure does not return a value. Okay, that's really the big thing. There's no return statement, and as a result of that, when you get past those set of parentheses here, you notice that there's not a data type that's being declared, and there's no return statement. It will still accept parameters, in other words, arguments that we throw at it as particular data types, so it could be an integer, it could be a string, could be a decimal, whatever it happens to be. And then once it receives those things, it will have a whole series of programming statements that will perform a particular task. All right. So in order to call a subroutine, it's very much like calling a function in that we call it by name. The name is case sensitive. And we would pass to it whatever arguments we have or whatever values that we're throwing at it, separated by commas. Now, this is important for both functions and subroutines, folks, that the order that you list those things in the function declaration. So if I expected an integer and then a double and then a string, I better be sending them in that exact same order. So if it expects integer, double, and string, I better send in integer, double, and string, not double, integer, and string, because it won't work. All right? So that's something that's important. The one thing that's notably different here, though, about a sub-procedure call is that we don't need anywhere to store a value that it's returning, so there's no equal sign present, right? We just call it by name with the parentheses that follow and put in whatever values it needs, and then it just does it. Why this might be useful? Well, just say, for example, you were outputting a certain series of text statements. Well, that might make sense, for example, like if you were printing out, let's say, a receipt for a cash register, that maybe the very top part of that receipt had the name of the store, the address, the phone number, the date, the time, and that just always just prints, right? So you might have a little thing that's called, you know, print receipt header, and it just does a series of statements and finishes. And there's nothing else that really needs to be returned. It just does its job, and then it's waiting for the next time it's called. All right. How do you name it? Well, basically the same way that you would name a variable. Names have to be unique. They are case sensitive. You don't want to use any of the language keywords or reserve words. So for example, I couldn't call my sub-procedure function because that's a reserved word. So I think that's pretty easy to understand. But let's take a look at an example here for passing values. In this case, we have a subroutine called display sum, and you can see that it's got two spots there where it's receiving those values. Both of them are accepting of doubles. When I call display sum, that's that first line right here, I just call it by name, followed by parentheses, and throw in two numbers, separated by a comma. When it finds the subroutine, it takes those two values, and in the order they're presented, it inserts them into these variable names, and then uses those variables and those values inside here to do the work. Now notice this sets up a separate variable of its own. It adds those two numbers together, stores it in Z, and then it gives us an output statement. And it's done. This is not returning a value back to the program somewhere else. In this case, it's handling the output directly. And that's not an unusual way to work. So notice here, he's trying to make a point too, the author, of kind of the terminology that we're using when we're moving stuff around inside of a program. And we call it passing values. But there are kind of these formal names that you'll hear when you learn programming of both arguments and parameters. And it's all relative to the point of view of where you're speaking from. So if I am calling a function or a subroutine and I'm sending it a value, I am passing arguments to it. That's what it's called. From the receiving standpoint, if I'm inside the subroutine, I am receiving parameters. All right? You might want to make a little note of that. You might see that in a test. I'm just kind of giving you a little hint there. So arguments from where you're sending it, parameters from where you're receiving it. If you really don't remember that really well, just remember you're passing values around and that those values are received in the order they're expected. So the 2 will end up in the first spot, the 3 will end up in the second spot. Up here where we're calling it, they're called arguments. Down here where we're receiving it, they're called parameters. So if I have a subroutine, can I just sit there and call it over and over again? Yes, absolutely. That's kind of the point, right? Because if I had, statements, let's say display sum had 15 statements inside of it. Why would I want to write 15 statements and 15 more and 15 more? It's absolutely silly. So you create that thing once, it's in memory, and all we have to do is call it by name, and it does its work. Simple as that. We do have to send it the values that it expects, and yes, you can do it multiple times. So, can I pass both strings and numbers at the same time? Absolutely. You absolutely can. The whole trick to it, though, is to remember that if I have a sub-procedure called demo that expects a string first and then a double, I have to send it in that order. Send a string and send a double. In this case, I'm sending literal values, right? Hard-coded string and a hard-coded number. But if I were passing variables, which I can do, they have to match the same data type. Note at the bottom that if I were to switch those two things around, I'm sorry, language is not smart enough to figure out that you got it wrong. And it won't switch it for you, it'll just throw an error. It has to be in the correct order. All right, so if I can pass a literal value, something that's hard-coded, and I can pass a variable, could I also pass an expression? Well, guess what? You actually can. Can I pass 2 times p over? Sure, because it'll just do the math first and then send the value. That will work just fine. Can a subroutine have no parameters? Sure. I mean, look at this example, right? Here we have a list box. This one clears the list box and then displays a message. That doesn't need to receive a darn thing, and it'll still work. So when we call it, we leave the parentheses empty, and then when we create it, we leave the parentheses empty. It still does the steps that it requires. It just doesn't need any values to do the work. Another thing that's kind of interesting as well is that you can actually have a sub-procedure call another sub-procedure. Now this is where it gets a little bit deeper, right? It goes like one layer deep because we are calling that demo sub-procedure we saw in the previous one. And then when we come inside here, then it calls the other one. And then does its work. And that's absolutely fine. There's no reason to recreate code. You know, if the described task code is pre-created, why recode it here? See the logic there? So that's absolutely allowable. All right. All right, another thing we're going to talk about here is the concept of how we pass our values. So there's two different forms for passing values. One is by value and one is by reference. And we'll learn kind of what the difference is there. And you know, that's probably, those two bullets are really the real important ones here more than anything else. And then the author does talk about a couple of different things. All right. All right, so let's look at this slide here. So the author says, ByRef keyword. Parameters in sub-procedure headers can be preceded by ref. And what that stands for is by reference. And what we're referring to by reference is the fact that we are going to be referring to a memory location that's storing a value. So there's the two different approaches. By default, things go by value unless we say they're by reference. So in other words, if I send a value to something, that value is sent and used to do whatever work the subroutine or the function is going to do. The value that we're passing does not change. That's kind of an interesting concept. Unless we use the ByRef keyword. So if we're changing that value in the subroutine or the function, then it will become changed. Otherwise, we're just passing the value and then it just does its work and doesn't change. Really kind of a good way to see how that works is to take a look at some examples. So let's start by looking here. So this one's got a little program here. Click the button. We have a variable called n. It's a double, which is 4. And then we run a little subroutine called triple n. So we're going to take 4. We're going to send it down to triple. It's received by triple right here. That number, notice, gets moved here. Excuse me, from here goes here, does the math, we triple it, and it gets stored back in number. When I take that n here and display it, what number is going to display? What's 4 tripled? Come on, second graders. I'm just teasing. 4 times 3 is 12, right? But ironically, up here, it's going to display 4. Just because I sent the 4 down here and it got multiplied by 3, it does not change the original value. That value got passed by value. So here's the concept. It got sent down here. We did whatever we did with it, but did not change the original value. That's the default of how programs operate. All right, and that's called passing by value. All right, take a look at this one. Here, we change the variable name up top from n to num. Now it'll change, right? No. Even though we're using the same name, when it hits this subroutine, this is handled as a local variable here. And even though they have the same name, not really a good idea to do that, but if you do, just so you know, it's not going to change the value of this one up here because it's passed by value and not by reference. So what happens when we actually do pass by reference? We use that keyword, and then that parameter is given the same memory location. So what it's saying is, I'm referring to this variable over here, so when I start changing it, you make that value stick. So looking at the example on that one, and then notice, even though we're going to be using a different name now, right? N is 4. This goes back to the original example. We send it down to triple, so the 4 gets down here, but notice that when we're passing it, as we precede its call, we say we're passing it by reference, which means that wherever we're sending this from, those memory locations are tied together, even if the names are different. So num here is acting as n, and when I multiply it by 3, and it comes back up here, it will actually turn to 12 in this case, and that's all because I used the by reference keyword. So now remember this, passing by value is default. I don't need to declare that, it just happens. But if I want that to change with whatever happens to it when it's passed around, I say by reference, and even if their names are different, here it's called n and here it's called num, they share the same spot in memory, so it will change if it changes here. You see that difference? Now that can be used, you can leverage that in your program design, because if you're, for example, trying to add up your bank account and keep accruing interest, you want to keep accruing that interest, right? You don't want to have it accrue interest and then have it drop back down to the original balance. All right. And I'm not sure if there's a difference between these two slides. You guys see a difference between these two slides? It looks exactly the same to me. I think what he probably meant to do was to probably, I'm guessing, call this num, and it's probably a typo. And it doesn't matter what it's called up top, and it doesn't matter what it's called down below. The author does indicate that one of the more common uses of by reference is when you do get input. So if you're running a subroutine whose job it is just to pull in some input, it makes sense that those values are tied together. All right. And that's not an uncommon thing. So if you think about how you handle your forms and how you handle input from your forms, it's not a bad idea to set up a separate subroutine that just is called input data or something like that, or get input or something like that, that is tied by reference back to the original program. So subprocedures that return a single value by ref, generally should be avoided. So in other words, you don't really want to use a subroutine to act on behalf of a function. Because when you throw in that by reference thing, you're tying variables together, so it kind of does that. But it's usually considered a better idea to actually use a function in that regard. And that's really going to be kind of dictated largely by situation more than anything else. But if you find yourself needing to return a value somehow, really a function is a better choice overall. All right. Well, let's talk a little bit about lifetime and scope. And just a definition here, because lifetime is kind of like a new thought. It says, the period during which it remains in memory. So what we're talking about here is variables and things that are running active in memory. So as long as your program is running, the program that you're running grabs those memory resources and holds on to them. And the lifetime is considered basically as long as that program is running. The scope, I think that at this point you guys are probably starting to see the fact that when you're inside of a function or a subroutine or a separate block of code really, that those variables are isolated unless you're using that by reference, in which case then you are tying them together. Now, why did we really come up with this whole concept of, putting things into subroutines and functions? Because when you start to take things that you're repeating over and over again many times, it really makes sense to bundle them together and call them by name. And then when you're running your main program body, usually the result of a button click or something like that, or a key press, it's so much easier to read through what the logic of your code is by just looking at the sub-procedure names. And then, of course, you branch off to all the separate ones to figure out what's going on. The other thing that's kind of nice there is basically it's saying here that they're just easier to debug. That's true because it's broken down into one little segment of code. You can isolate problems to a particular subroutine, and if you're writing programs on a team with a big group of people, that's often what you do is you'll assign people, okay, you write this one, you write this one, you write this one, and then you might come up with an agreement about what's being passed back and forth by reference, by value. Is it returning a value? Is it not returning a value? And it just makes that whole process, I think, significantly easier. All right, he's got a couple of things here that he mentions. If you want to read those, go ahead. Just a couple little notes here at the end. It says, both of these can perform similar tasks. Both can call other procedures. And use a function when you want to return one and only one value. You can't return multiple values with a function. All right, what I'm going to do at this point, folks, is we're going to take a short break and we're going to come back and finish off the remaining slides, and then we'll go and do some lab work. So we're going to take 5 here in class. All right, now that we're back from break, we're going to go into the last section of the presentation here, which talks basically about program design. And if you guys looked at some of the materials that I posted in the previous unit, I had a little section on structured programming and what it's all about. And that's really kind of our approach here overall. So let's take a look at this concept here. Well, one thing that you guys are learning here as you're writing programs and you learn how to pseudocode and take things step by step, and that's fine when you have these really simplistic little programs. But real applications tend to be a lot more complex than the stuff that we've been building so far, and I'm sure you guys have probably noticed that. But the way that you solve a real large programming problem basically is by breaking it down into small little pieces that you can solve one by one. That's really kind of the approach. And really, large programming problems usually are collections of small programming problems put together. And some people will, as I was kind of alluding to before, will use this divide and conquer approach, where if we had like a team of programmers working on an application, I might say, you write the part that calculates tax, you write the part that writes the total, you do the part that calculates the wages, and we'll pass this many parameters, and we just kind of break it up into little pieces. And that is an okay approach, and often they'll call it stepwise refinement. But it is still part of what we call it kind of a top-down, step-by-step approach, that method. Now, the whole point of that top-down design is that we take what we call kind of the main portions of what we're trying to do, and that'll be sitting at the top level of the design. And then as we start to break it down into pieces, the more specific tasks will start to line up under those more general ones, piece by piece. So what happens is we actually start using kind of a combination of these two approaches, and really the point of it is that hypothetically makes our lives more efficient and and better, I guess, from a programmer standpoint. Now here it says, from a top-down design criteria, it says design should be easily readable and emphasize small module size. So if you are going to break things into subroutines and functions, breaking them down into little specific pieces make a lot of sense. So you might get a subroutine that just gets the input from the form. You might get another one that just does the calculation. You might do another piece that just does the display. That would be an example. And as we're going to see here in the upcoming slides, you kind of use the top-down approach, and this is what the hierarchy charts are kind of all about. And I don't know if you guys remember when we were talking about this very, very briefly in the first chapter, and I kind of skipped over the hierarchy charts because they really didn't make a lot of sense back then. And now I think you'll start to see why they might make sense when you start to use subroutines and functions, because of the way that you break down the tasks and the ways that you break down a problem. So actually, let's just jump right to the charts. So if you were writing a program that might calculate a car loan, you might think of that problem as maybe these three larger steps. So you get input, you do some calculations, processing, right? And then output. Remember, input, processing, output, those systematic steps. But the reality is those steps are a little bit more involved, right? So if you're going to get input, you'll get much more specific information. So you have actual specific components you need to get. And then when you do your calculations, well, those calculations really aren't quite so straight ahead either. So you might actually break those down into separate components as well. And whenever you see these things breaking down into pieces, they might indicate that you need a whole subroutine for it, or that might be a portion of a subroutine or a statement within a subroutine. But you start to see the pieces. That's really kind of the whole point. And then how you group them together really becomes up to you. But you'll start to see a problem in very much that fashion. And that's kind of the way that you should approach things as a programmer in terms of when you're dealing with a large programming problem, how you break it down. Think of the larger steps from a general standpoint, and then when you have those steps, the little individual pieces that come from that. Structured programming as a whole, and this is something I've been trying to revisit as we go through the course, but we, remember, can solve any logical problem by using these three approaches. Doing things one step at a time, sequential, making decisions. Sometimes we have to choose one path or the other. Those are called decisions. And then what we'll see in the subsequent chapter, when we get to chapter 6, we start to talk about looping, and how you'll see that there's certain actions that are repetitive. It certainly doesn't make sense to keep writing the same code over and over again when you could just write a command that says, do it this many times and be done. So those three approaches will solve just about every logical problem there is. So why is it good to use structured programming? Well, things are easier to put together. They're easier to understand. They're easier to change if you're dealing with somebody else's legacy. Having something that's easy to write helps, because if you're trying to think of a whole programming problem as one whole piece of code you have to write, that becomes a problem. If you start to think about it, well, I'm just working on the output statement right now, that's pretty easy, right? And then it's not quite so intimidating. And by being able to break it down into those pieces and identify parts that are really easy to just cross off the list, all of a sudden you start crossing stuff off your list and you have very little left to code. And you'll find that the difficult stuff really isn't quite as difficult. If you set up your programs correctly as well using sub-procedures and functions, it also makes it a little bit easier for other people trying to debug the program, or even for yourself to debug the program, to be able to trace down what's happening. So if you have separate routines for doing specific calculations, and in your main program body, usually the responsive button click, it'll say, calculate car loan, display car loan. I mean, those are pretty easy to understand. And then if you're having a problem with a display, you know where to go look for it. So that is an important part of it as well. if you name things well and you structure things well, it also kind of, in a sense, self-documents the program too. So if I say calculate interest rate on loan, and that's a function, that's pretty clear as to what it is. So it's easier to change it as well because I don't have to hunt around for it. Ultimately, all this stuff kind of leads us to this whole concept of object-oriented. Object-oriented really kind of takes things to a little bit higher level, and it's really the modern way to program. And what's cool about that is object-oriented allows you to kind of like pre-create constructs and then instantiate those constructs. Kind of like, for example, you develop a blueprint for something, and then you create the actual thing based upon the blueprint. And that blueprint, by its very nature of design, will have sub-procedures and functions and capabilities built right into it. We don't really do object-oriented in this class, but if you guys are in the software programs or the web programs here at Gateway, you'll notice that we do a lot of object-oriented programming, and that's really kind of the modern approach to doing things. All the stuff you're learning here all fits within it. It's just taking it up one more level. It's basically the whole thing. Now, one last slide here that the author kind of, I think, kind of haphazardly threw in at this point is the fact that, remember, we had an exit function statement. You can also throw in an exit sub-statement. And those are usually tossed in to conditional statements. So you might have like an if statement or a select case statement where a certain scenario would stick and you just pop right out of the subroutine. All right, folks, that wraps the slideshow here, thank goodness. And now we're going to move into our first lab assignment here in class. So I would encourage those of you listening to the video to do the same thing. This video ends here.